Hello everyone, welcome to this episode. Here we are going to do another problem today, which is a gas station question. So the question says there is a given list of gases. So there is a points for every point. Let's say there is a n elements in all these both these arrays, gas and cost. And the problem says uh, that for gas I, the cost is going to be I. And what we need to provide here is the point I, which can complete a trip. And the trips are going to be kind of circular here. Circular trips. Yani ki if let's say I'm starting from a I point, I can again go through it to I plus 1 and all to n minus 1 and then to 0 and then to up to I minus 1. This should be my trip. So it's a circular trip that I need to complete. I need to find a point if it's a valid point of start, which can give us a still a valid trip. So what is a valid trip? Valid trip is where we don't we don't get emptied with our gas. We still are able to. We should must have the gas to move ahead with the given costs. So first we'll talk about the brute force approach here. So I will just write the brute force approach. What should be the brute force? So first of all, there is a size of this given array. I'm just going to take gas or cost as a our base, which will provide the size. And that for this n, I will just start a for loop, I less than n, then I plus plus. For this for loop, if I see at every point there is a cost, so I will just write it as a diff. So what is the cost at point I? Gas of I, whatever the gas is there, and cost at I. So if we see at this point I, this is going to be my gas, and this is going to be my cost, and the difference of it is going to be the amount which is going to be carry forwarded. So if we see the basically if diff is less than 0, then this cannot be a valid point of start. So that is our basis here. We should continue, we should move forward. At the end, we can say we return -1 if it is not found. But here we are just putting a continue if such a point exists. So if the point is a valid point and if is greater than 0, in that case, how we should handle? So we should handle through a while loop. So what we are going to do, the current index, we'll just define it as a j, which is going to be our I and the percent of n. Why I'm doing percent of n? Because this is going to be a circular motion from this point I. So this I is a valid point that we have found. So what we are going to do, we are going to evaluate for the next point, next set of points. And what is our evaluation point for this while loop is j, this point is not equal to I. So if it comes, it means it has already completed a loop. And if it completes the loop, we need to see if j equal to I. If it comes with the valid loop, then this is our valid point. If let's say, so now we are going to write what should be in the while loop. So if there is a while, j is not equal to I, then we are going to see if uh, the total cost. So let's say there is a total cost that is given 0 for every iteration. For every point we are going to so what we are doing here, we are for every point I, we are going to define a total cost and a kind of loop we are going to iterate. over, and in this loop, while loop, you're going to see if this total cost is less than 0. This is what we are going to check. What this total cost will be. If this is get less than 0, then this is not a valid point. We should break this loop. If it is a valid point, then we should use this j. If total cost less than 0, if it is not less than 0, then it's a valid point. And in that case, what we will do, so how the total cost is calculated, total cost is equal to plus equal to the diff, and that diff will be, if you say that this is going to be gas at j minus cost at j. This is our total cost. If it is there, then this total cost, if it should not be negative, and every time the j is going to increment, j is equal to j plus 1, and which is a divide by n. Why the modulo n? Because it should it's a circular motion. It should go into a circular motion, and the j should again come back, and if should come back at a point where it is the same as I. So that is what we are going to check. If so, this is how we are incrementing j and with a modulo of n, so that I can come back again at the same point. So this is our solution. If we run this, okay, there is -1 where have I done some mistake? So it seems like I've done some mistakes. So this total cost, I'm doing 0. So it's not taking care of the actual diff that we calculated here. Basically, I should evaluate it to diff, and that diff should be moved forward. So if I just try to do this, yeah, it's working. But if I try to submit it also, it will try to take it. It's accepting. Okay. But the problem here is this is a brute force approach, and how many times the loop will run. So this loop will run for n times, and this will also run n times. So it's a n square time complexity. Space complexity definitely is 1. It's a static space complexity, but it's a n square and the time complexity. This is not a optimal approach. So we'll go with our another approach, which is going to be the improved approach than this one. I'm just going to comment it out, and we are going to write it in a different way. So what we are going to do, we are going to improve it. For improving it, we are going to take care of it in a different way. So first of all, we know one thing, and I am just going to copy a few things from the last iteration, which we are going to need here. Gas dot size, gas dot length. So this is our n. And first thing is, if let's say we define the total cost. So total cost initial is 0. We should see if this is going to provide us a valid solution or not. That's the first check that we should do. So I'm just going to start a loop to validate that. I less than n and I plus plus. I'm going to start a valid loop to see if the solution is possible. So total cost, I'm just going to do the check for the diff, which is a gas of I minus cost at I. And whatever the total cost is, if total cost is less than 0, it means it's not a valid, it's not going to be a valid solution. And at this point, I should just return -1. There is no valid solution possible for this one. Okay. So this is one thing that we should be clear of. Now, how we can get the actual solution if it is a valid loop. In that case, again, we'll just have it a loop. And the valid solution, what basically we will need. So here we are going to think about of a prefix sum, and prefix sum with kind of a Kadane algorithm. Kadane says base if the total sum to the so we are going to evaluate our contiguous sums here. So we know that a point which is not valid cannot be moved forward. So if at a point, let's say at a current point, the overall sum goes negative, then we should start over and we should not consider that point. We should start over. So we are going to keep track of this as a total sum, which is 0, and then as a current sum, current, I can just mention current, and then there should be a start index that we are going to keep track of. Let's say at the beginning, we are starting with a 0 index, and we are going to start our exploration from 0th index, assuming a 0 is a valid point. So here, what we'll do, we'll see the total sum int def is a gas of I minus cost of I is our def, and the total. So this is going to be our def, and the total cost will be equal plus equal to def, and current is also equal to def. So think of it in a case where, so we are exploring two sums. Total will explain about the same as total cost, and the current is what is it is going to be like the current sum, so current path sum. So what we are exploring is the current, let's say, and if this current sum goes less than 0, then definitely this point, whichever we were exploring as a start point, is not going to be a valid point. So what will be our next valid point? That will be defined by, let's say, I plus 1, you can say. So if let's say there is a current plus is less than 0, in that case the current will assign it as 0, a start will become I plus 1. Now this is a very important point that we are writing here. So at whichever point it becomes less than 0, let's say we were exploring from 0, there is an array of 5 as a size. We came till 2 point index 0, 1, 2. And now we see that current is less than 0. Then we are not going to consider, we started from 0, and at 2 we found it's negative. Then we are not going to consider any of the in between points as a start point. You see, if 0 is not valid, 0 is not a valid as a start, and that we found at 2, then in between that, whatever points are there will not become as a valid start, because something is going to diminish our overall value and going to make it negative. So that any of the middle point is not going to be our start point. So this is what we are doing here. And at the end, when we are done with it, then we will say if return, if the total sum is less than 0, then return -1, as it means the solution does not exist. Otherwise, you can just return the start, and that start will become the point where it should work out for us. So you see, this is working. And this is a solution. I hope I have tried to make things clear. And the overall time complexity for this solution is n, and because there is no inside loop, you see, and the space complexity still remains 1, O of 1. Okay. So yeah, thanks a lot for being in this video. We'll meet you in the next. Thank you.